Thank you, everyone. So this morning we heard from Phil, who got us to glass, that initial loading stage of websites. But what's next, right? We've got interactivity. And today I'm going to be talking about how this kind of interacts with web performance. And, the perfect time of day to bombard you with an enormous statistic. Everyone's just had lunch. You're maybe flagging a little bit at this point, but we will come back to this, so don't worry if you can't take it all in one go. So a quarter of all websites completely block any visual feedback from happening for more than 200 milliseconds after a given user interaction on a quarter of all their page views. So as I say, there's a lot to take in there, and we will come back to it. But effectively, what this represents, it's a text-based summary of where we stand today as an industry with Interaction to Next Paint, which is Google's latest official core web vital as of March this year. So I've been particularly excited about this metric because for far too long, we've been just primarily focused on this kind of thing, looking at waterfalls, seeing how websites load. We have been, understandably, we've been very network constrained. We've gone from, GPRS, 2G, 3G, 4G, and now 5G, and we're starting to see improvements there. But interactivity has just kind of got a bit lost. We have had some metrics. We've had things like time to interactive you might have heard of, total blocking time, or even first input delay, which is the predecessor to IMP. But all of these have really still been focused around that kind of loading phase. Even our kind of analytics tools as well. They've traditionally, things like Google Analytics back in the day, focused on kind of page view to page view rather than what interactions were happening on a web page. But there's a massive opportunity here. There's a whole bunch of different case studies showing that pretty much every different business metric can be improved if you address IMP problems. A lot of people are coming from this from the kind of SEO angle because Google do use that as an element of their kind of ranking. But whether it's direct sales, whether it's content consumption, whether it's bounce rate, whether it's page views, whether it's literally like views of adverts, IMP correlates to improvements in these areas as well. And that's because 90% of our time is actually spent after the website has loaded. So we've just been kind of trying to ignore this for a few decades now. So if we go back to that very extensive text summary, we can start to kind of break this apart. You might be someone here today thinking, yep, hands up, I know I'm in that 25%, I know I need to improve, that's why I'm here, and that's wonderful, and we will get to that. But you may have also looked at your IMP rating and looked at what Google said and said, yep, they're telling me it's good, everything's fine. But there's a lot of nuance in here that kind of gets lost, and for a lot of companies, it's just simple as, good enough isn't actually good enough. So let's start to pick apart this metric. You might be thinking, well, a quarter of all websites isn't that bad, is it? Really? It's not the end of the world. But, and we have improved since IMP was first introduced back in 2022. This was when it was in beta. This data started getting collected. And back then, 44% of websites were failing. So we are making inroads on it. But that's typically coming from third parties and big platforms where we now have this attribution data that tells us where these problems are, so they can go away and they make one little change and suddenly everyone on the web who uses them benefits from that. So we see these massive jumps forward. But if we look at the bit that we control as developers, it doesn't paint such a rosy picture. These are frameworks and libraries that have been pushed as kind of the de facto defaults just to use on every single project for the past decade plus now. And they're marketed as being instant and rapid, and they're still being pushed today. There are some glimmers of hope, and ultimately correlation doesn't prove causation, but you can see clearly that your mileage will generally vary depending on the tools that you choose to adopt. That may be down to the initial out-of-the-box performance of a given tool, or it might be the knock-on impact of that tool that it has on your ability to go away and optimize and make changes. How far abstracted from the kind of raw materials of the web, the HTML, the CSS, and the JavaScript, how abstracted are those from you? How much control do you have over those materials? So the next piece, blocking visual feedback. This is where it starts to get derailed a little bit because we've got interaction to next paint, so it sounds fairly obvious. An interaction occurs and we're timing how long it takes until the browser next paints an update. But in reality, this is Google's diagram as to what gets measured in IMP. This section over here that I've kind of grayed out, this is the kind of painting section. This may not actually happen. You may have an update, someone might click a button, and there may not be a resulting paint. You may have missed out a loading state, for example. It's just simply waiting around, nothing's happening. So what we're measuring IMP is the actual potential for there to be a paint. How long are we actually blocking and preventing anything from happening? We're not measuring exactly when something did happen. So even though the threshold is at 200 milliseconds, and more on that in a second, things are actually far worse than that. So on that 200 millisecond piece, you might be thinking, well, that's pretty tight, right? 200 milliseconds, who's going to feel frustrated about less than a second they had to wait, people are, attention spans are low now, but 200 milliseconds is not a lot. But ultimately, 100 milliseconds in terms of kind of human-computer interaction research and things like that, it's been the standard since the 60s. Google's own rail model states 100 milliseconds to ensure things that feel immediate. We classify 50 milliseconds as a long task or a long frame in a browser, so that we ensure that if two of these things collide, then that doesn't breach that 100 milliseconds. And if you want to paint at 60 frames a second, if you want a nice buttery smooth animation or something like that, then you've only got 16 milliseconds of time, so it's even tighter. But if we step back a little bit and look at actual business data, SpeedCurve, which provide a real user monitoring tool, have found that for a lot of their clients, they've seen correlations of a drop-off in conversion rate from just 100 milliseconds. So we're actually seeing this in the data as well. Next piece of the puzzle, hopefully this one isn't so controversial, but it's a good point to introduce what kind of interactions are measured with IMP, because not everything is measured. So clicks, key presses, and taps, on your mobile phone. Those are measured. Scrolling, hovering, and zooming aren't counted because effectively the browser can kind of optimize those things, and typically you're not triggering a lot of JavaScript. So with these different types of interactions, you have kind of different thresholds as a human being for what's going to feel frustrating. Clicking on a button, seeing a 200 millisecond delay before it switches to a loading state, maybe almost invisible to you. That may not necessarily be a problem. But I actually gave typing a go with a 200 millisecond latency on each key. And, we had Sarah talking about cognitive load earlier. This was really difficult. I made lots of mistakes, and going back to even correct my mistake was really difficult as well. So I really encourage people to give this a go. The URL's at the bottom left corner, and obviously you can grab the slides later as well. So, last piece of the puzzle, at least a quarter of all the page views. And again, is a quarter that bad? Well, I've spent 2 decades in web development now, and the majority of my career in web development has been surrounded with kind of e-commerce related topics. We'd cross-browser test things that are less than 1% adopted. We'd A/B test to eke out every little percentage. So simply just ignoring 25% of the data isn't really acceptable. If we're really caring about our users, we need to be caring about the 95th percentile or the 99th percentile or even greater. And if we look at IMP, you can see that most websites have a distribution that looks a lot like this. So this is a website that's almost passing. You can see it kind of breaches it at the 70% percentile. But for 15% of users, they're seeing interactions blocked for over half a second. So it's a lot worse. It ramps up exponentially. And this could be coming from one critical area of your website. It could be a really performance-sensitive area. So I just want to hone in on that last part a little further. And I promise this is the last time I will show you this immense statistic. So page views. So IMP is recorded as the worst interaction on a given page view. Now, There's a little asterisk here because actually, if there's a lot of interactions, say you've got a chatbot or something like that, and obviously people are going to be using that for a long period of time, they're going to be typing in the boxes, etc. 1 in 50, the worst 1 in 50 gets discarded. So really, it's like the 98th percentile of interactions that gets recorded. Now, the trouble with this is that because it's recorded at that kind of page level, and obviously we're building lovely interactive websites these days and web applications, it means that we're not getting a true picture of that page. It could be one slow interaction. It could be that you've got one of those annoying, like, 10% off your first order banners, and just closing that is really slow, but then the rest of the website's really fast. Or it could be something like a chatbot, but every single character someone's typing is really, really slow. And if those two numbers are the same, it's going to be reported as the same. You don't know whether it's slow all the way through or whether it's just one outlier, one interaction. So that's one issue. We're kind of lacking the distribution of the interactions. And on top of this, it doesn't actually give us an accurate view across an entire session of what people are feeling. You know, we could have one demographic who are on particularly slow phones or slow, maybe scenarios where you might have low battery, and they might be experiencing these kind of really slow interactions on every single page view that they come across. Or it could be just evenly distributed, so everyone is equally likely to have this terrible experience. So ultimately, generic metrics and thresholds are really difficult. And I think a perfect example of this, given the kind of health and fitness theme of this talk, is my body mass index. So I know I'm not the most svelte guy. I could probably do with cutting down on the carbs a little bit. But I'd be surprised if people said I was obese. But that's where I am on the scale. It's just, it's just a medical term. And, commendable to our NHS in the UK that they do go into a lot of detail explaining that, as you start to put on a bit of muscle, this falls apart as a metric. But like BMI, the Core Web Vitals are trying their best to be as generically applicable to everyone as possible. They want to be relatively stable, so you're not chasing something that 1 minute is passing and the next minute you're failing. And they want to be achievable en masse as well. It's pointless putting out a new metric where no one can achieve it. It's like, 1% of websites can pass, and then everyone just gives up even trying. That wouldn't achieve a great deal. So, it's great for industry trends. We can see how the industry is performing. And it's great for knowing that you definitely have a problem. But without digging deeper into it, if you are passing now, you might be leaving a lot of money on the table. So wherever you land on this scale, whether you've looked this up or not, let's look at how we can improve things today. How can we analyze things and get on top of it? So to start digging, you might reach for the performance tab in the Chrome DevTools and start looking at the flame charts, but I get intimidated by this stuff, and I do this day in, day out, so I don't expect most people to be comfortable with it. And really, this is only necessary in the kind of rare situations where you're really kind of getting into the nitty-gritty, and you may be really struggling to figure out where the problem is. But for the majority of problems, there's far easier ways to look at this. And on top of that, this only gives you a view of the data from your own laptop, which may be like an M3 Max or something like that. It's going to be mega powerful, completely different to what your users are using. So a better place to start looking might be the Google Search Console. This gives you a little more fine-grained detail than like the basic crux data that you get out of Lighthouse. But you're at their kind of behest as to how they group URLs. This is only a very small website, but they've built 2 groups with 148 URLs in here that don't follow any pattern of the URLs. They've just chosen to do it that way. So, and I'm getting these kind of figures, but I'm not getting any degree of attribution. So the easiest and most detailed option is to go out and buy yourself a real user monitoring tool, something like RunVision. This will give you all the data, all the attribution in a really straightforward UI. I'm not paid to say this is just what I'm using with one of my clients. And you can see here in this kind of middle section, we're getting a rating on every single script on the website. So you can actually dig into where any slowness might be. I could actually go further into this. I could look at individual functions within those scripts. I could look at individual event listeners. I could start slicing the data on things like different page templates or device types and all that kind of good stuff. So you can really dig into things and get to the bottom of your performance. But these tools aren't free. And some people might already have like data viz packages and analytics, etc. So another option is to use Google's webvitals.js library. This is just available on GitHub, and you can install this on your website. It will help you collect all the data, and then you just ship it off to your own solution. And the data looks a little like this. Now, I don't expect you to be able to read this. It's very, very small. I just wanted to show you kind of how much you're getting. So if we start to zoom in on this, you can see right at the top up there, you can start to see the overall value of an IMP. So this might be just one interaction on a page. You can see the kind of rating that's been given. We can see the actual path to the DOM element as to what was interacted with. So it starts to give you some clues as to where the problem might be. And we can actually see scripts that were running during that time, how long they were running for, when they started and ended, etc. And again, that lets us see what's executing on the main thread of the browser that's interrupting this interaction. So obviously that's quite a lot of data to dig through. If you just wanted to give this a go, you just want to flick around a few websites, get comfortable with the data, you can just install the Web Vitals extension, which uses that library behind the scenes. And again, you don't get a true picture of kind of real usage here, but you can get comfortable with the data. So this is only really kind of truly useful once you've found a problem in your RUM data or deeper in the kind of crux data, and you're kind of iterating on fixing it locally. But that said, it can be humbling. There's an option in the tools under the performance tab to throttle your CPU down to as low as 20 times what it was. And yeah, that will be humbling for most websites. So it can be interesting just to give that a go. But ultimately, whichever solution you look at, you'll start to see this kind of breakdown with IMP. You get these three subparts. We get input delay, we get processing time or processing duration, and we get presentation delay. So we can start to understand what our problem might be. And I have put an extra little slide in here today, just because there's a new experiment in Chrome Canary that gives you a little dashboard. This actually means that you don't need to install the extension. It comes natively within the browser, and you can literally just click around the page, and they appear just in this bottom section here. So really good stuff there. So if we return to Google's diagram as to what is measured within IMP, you can see these three distinct parts. We've got input delay, processing time, presentation delay. And one of the kind of first things to understand here is that our input delay is pretty much caused by other events happening. So you can effectively remember that one interaction's processing time, its render and paint, can become another's input delay. So if we're starting to look at how we optimize these things, you might use optimize JavaScript in that middle piece, because that's predominantly where the problems are going to lie. When it comes to rendering and paint, we need to look at our CSS and our DOM. And then if it's input delay, we need to look at both, because that's being caused by those two things. So we know we have a problem. What next? And this gets to the title of the talk. I was inspired by conversations with my personal trainer, who talks about parallels in the tech industry to health and fitness. Everyone jumping on new trends. I complain about people who are just saying, okay, well, Netflix, Amazon, Google, etc. are using this. I need to be using that technology, and it's like you're very different. And he'd be like, yep, see exactly the same thing. People following the exercise plans of Olympic athletes. And they train like once a month. It's like you're very different people. You need something that's tailored to you. You need the right tool for the job. So we can choose to go with the fad diet. We can choose to switch to yet another JavaScript framework. The next person who promises is instant. The next thing that we get marketed. Or we can take things into our own hands, and we can actually start to understand the web. We can understand and take ownership for how we build for it. How we build for our users rather than just trying to take shortcuts. So today we're going to cover two kind of fixes for IMP along those lines. So first we're going to look at how do we let our main thread breathe. Most of what happens on the web is happening on the main thread, and that's how these interactions can slow down. So what tweaks can we make to our existing implementation today that will help this. And hopefully we'll have time for this section. There's some amazing advancements in the web platform APIs that are kind of chipping away at our need for these large frameworks and libraries. And hopefully with these things combined, you can have the same success that I did. And this is on a recent client website where we relaunched and got their IMP from almost in the kind of poor section well into the green section. It wasn't quite 100 milliseconds, which was what I was aiming for. 103 I'll take. So the easiest thing to do is just delay processing any of your interactions. So you just set a timeout and wait for the code to execute maybe on the next trip around the event loop. But this is not really going to work. This is kind of cheating the system, so really don't do this. Effectively what you're doing is you are allowing the next frame to happen, so IMP will be like, yep, this is great, but you will just be causing input delay on another interaction because once your JavaScript starts executing, that's then going to block other things. Because there's no visual feedback here, you're going to be causing rage clicks or even like accidental second clicks. And so therefore you'll upset your users and you'll upset Barry Pollard from Google. He somewhat jokingly said this, where we were discussing this recently, how you don't actually have to paint. And he was like, guys, come on, we've just introduced interaction to next paint. Don't make me change it already to next interaction to next meaningful paint. He was somewhat joking here because it does get caught, but don't upset Barry. So just don't cheat. The key thing here is that we need to make clear what is and is not interactive. So this is where our designer friends in the audience can help us. We're going to need some kind of uninitialized states, designed for a button that isn't ready yet. There's probably a better name for that. And then we're also going to need some loading states as well. So imagine you're a conscientious front-end developer. You've thought, nope, I'm going to server-side render my pages to make sure that we get to glass as soon as possible. But this button still needs JavaScript to work. But imagine we're kind of mid-page load. There's probably going to be a lot more going on than just this one button. But just bear with me for a second. Now, we're loading this page. There's a whole bunch of things kicking off. We're downloading images. JavaScript's flying in. CSS is being analyzed to produce the layout, etc. But our user sees this button, and it says, click me. It says, well, I can do. So they click it. Great. The trouble is that the main thread's blocked by all this other activity that's going on, and, well, you can see the impact. We get this massive input delay. This button does absolutely nothing. It has no event listener on it. It's just a HTML button. There is no JavaScript on this page. I think that you can see that just there, the interaction target, actually. And yeah, we get this 200 millisecond delay because it's waiting for other things to finish. And that's a really bad experience. People thought they could click that, but they can't. So that's why we need that visual state that shows you can't click it. But that's kind of half of the problem, right? We need to think about the loading state as well. Because effectively, when we're processing this in this particular order, our JavaScript can block that loading state from even occurring. So really what we want to do is swap these two things around so we get our render and paint done first, present the frame, and then we process afterwards. Now, by using something like set timeout for this, there is a chance that we can allow other things to kind of interject, and our main thread becomes busy again. But this is somewhat desirable behavior, because in that gray box there is probably another interaction trying to give some visual feedback. That's desirable behavior. That's what we want. And all we need is something as simple as this. We're just setting the button to be disabled, when we click it, so you can't click it again. And then we set the timeout, so this function will occur on the next trip around the event loop. There's a few little kind of foot guns here. Some people look at this and go, I could make that a little cleaner, maybe using something like async await, using promises, for example. But promises are effectively microtasks, so they don't necessarily yield to rendering, so you can't do that. You may have also heard of the request animation frame API. Now, again, this is used for a lot of kind of asynchronous delaying and things like that. But it executes before rendering. So effectively, we can't use that one either. So just a plain old set timeout. We'll get into more complex solutions in a little while, but a set timeout would just be fine here. So we've got our loading state, but even after just a couple of seconds, that thing gives me anxiety. It's not a complete solution. We can't just say, oh, we're giving them some loading spinners or throbbers or what people want to call them these days. That's enough, we're done. You can effectively see this as kind of resetting the timer in terms of people's attention. If we look at Ilya Grigoryk's kind of seminal book from 2013, High Performance Browser Networking, it's available for free online, I definitely recommend reading this. You can see it doesn't take much, like 1 second, to have a mental context switch. And 10 seconds, the task's abandoned altogether. To me, I look at this and go, okay, well, that book was over a decade ago when it was published. What do you think's happened to people's attention span since then? We've got like a war zone over our attention when it comes to social media and all these things like YouTube, etc. So we've given immediate feedback on that first interaction, which is great, but then what happens when another interaction comes in? We could be blocking that paint as well. So we might want to consider, can we delay our execution until further on? Can we delay to a quiet period, when the main thread's not busy doing other things? And yes, you can. There's another callback, request idle callback, and this is actually another cool little IMP pattern. I mentioned looking at our CSS and our DOM. Rather than just outright removing an element from the DOM, you can just hide it and then wait for the main thread to be idle and then remove the element at that point. And what that does is limit the scope of changes in terms of that rendering process. So that will be a little bit quicker. But the trouble with this callback is that it happens at the control of the browser. The browser decides when or even if it's going to execute this. It may never have a quiet enough main thread to execute. So you may want to add a timeout on here. A great pattern you can use this for is things like, if you've got some kind of non-critical analytics events, you can kind of batch them up using this and trigger them to fire off after, it's a second in this example, but it could be 5. So that's great. But we've not solved the kind of core problem of once our JavaScript starts executing, it just doesn't stop. It's going to block that main thread until it's done working. And again, this becomes input delay. So we want to take that processing time, and we're going to chop it up into little pieces so that other things can kind of slide in between these little chunks. We want to give the ability for these important actions to occur. And you could, again, just do lots of set timeouts. But one, this is really ugly code. Nested callbacks. Nah. I'm sure we could all tidy it up, though, if we spent a little time. But two, the trouble with set timeout is that it appends a task to the end of the queue. So that means that you might have something that's of relative priority. You want to allow things like other rendering and paint to occur, but then you want to crack back on with that thing. This has the problem of, if we've broken up our task, allowing another task to render, and then task 3 here has jumped the queue. So effectively that's getting in before our task 1 gets to resume, and then that might be delaying the render and paint from that task 1, which was actually showing something useful to our user. So again, we want to see whether we can bring that task 1 back closer, so it still yields to rendering and painting, but it doesn't just get lost and delayed further. And that's where the scheduler.yield API comes in. So this gives the best of both worlds. It yields to the main thread, allowing this to happen, but then it continues as soon as possible. It's a lovely, simple API, as you can see. Unfortunately, it is only in the next release of Google Chrome. So that's not ideal. But I've been checking all of the discussions with the Firefox guys and the WebKit team, and they all seem very positive about this API. It's not official support yet, but I reckon we've got maybe 6 months before they'll be introducing this there as well. So the great thing is that if we do polyfill this, you can just fall back to set timeout. It's less ideal, but it still works. And then, it's literally a few lines of code. So, you can start using this today. And the impact of this one little API cannot be underestimated. So I was watching a talk from Didomi, who are a consent management platform, the cookie monster. And they found that when they just yield after someone presses, accept or reject or, modifies their consent, they found that IMP on those actions improved 60 to 70%. So that's going to have a staggering impact across the web because they've got many clients using this. So, how about avoiding execution? Can we do that? Do we have to process everything? Even if we are yielding, we can still end up with a very busy main thread. Lots of things going on. So ideally, we want to limit how much it's got to do. And the all-time kind of classic example here is debouncing. Back in the day when responsive design was new and we were kind of adjusting the page with JavaScript a lot more, we'd set a timeout and then clear that each time someone resizes because it would fire on every single pixel as you change the browser size. Ultimately, we wanted to wait for the user to finish resizing and then process this action. So very simple bit of code. That's one of our options. The trouble with debouncing, though, is that effectively nothing happens until the user stops interacting. So throttling is another option. Effectively, this is slightly different because it limits execution to a number of times over a set period. So a great example here is something like type-ahead search. You may not want to render the results on every single key press, but as someone's typing, you want them to see some things happening. They are seeing some results come in. They might be slightly out of date because they're typing quickly, and then you catch up at the end. Again, we can just use set timeout for this. Don't worry about the code. You can grab that off the slides. Now, neither of these things, as I say, require a library, so nice and performant for your network side of things as well. And there's recently been activity on this issue as a proposal to actually natively integrate these two tools into the web. And the API for it would be very, very straightforward. This is kind of what's being proposed, just literally setting an option on our event listeners. So that would be fantastic. We get to remove so much boilerplate code, and it would encourage developers who maybe aren't so senior and comfortable with this code just to be able to add these options very quickly. So that's fantastic. But there is another option as well. If we've got something that actually wouldn't be that useful if it's out of date, we can actually look at aborting that as well. And again, there's quite a lot of code there. The main thing is that abort controller. That's the API that kind of encapsulates this stuff. But you can grab that off the slides. So a good use case to imagine here is if you've got a product listing page or something like that, a catalog that you're filtering on a web page, you might have a whole bunch of checkboxes. And as soon as someone checks one of those, we want to start loading in the relevant results. We want to make it as snappy as possible. But if they keep going along and checking more checkboxes, we just want to abort the last one and fire off a new request. So that way we're kind of showing only the most up-to-date data. Now, I appreciate that was quite technical. So here's just a kind of visualization of how this is breaking down. So with debouncing, we're kind of kicking the can down the road every single time an interaction comes in. With throttling, we kind of ignore subsequent interactions as we've already queued one up. And with aborting, you can see here we've got a very busy computer. It might be the main thread, it might be our network, but we just kill off anything as soon as another interaction comes in if it's not finished yet. And what you can actually do is combine these techniques together. So you can use throttle and abort, maybe with a short throttle window. So we reduce the amount that the device is having to do, but we are providing that feedback quickly, and then we're avoiding executing things once it's out of date. And there's a few final tips on that that are not directly related to interaction, but ultimately can affect IMP because we need to avoid executing JavaScript that could interfere with our interactions, right? So the first thing is just checking support for native CSS features. If we can do something in CSS and it's performant, then we don't want to execute our JavaScript that might do that. Similarly, if we're depending on a native API, we don't want to have to get through all this JavaScript only to get to the last little line and then not be able to execute it. So wrapping a conditional around that is great. And then finally, looking at the context as well. You might have some scripts that are providing kind of UIs that only are for desktop or mobile or other kind of context that we can test with media queries. Again, we can wrap that up. And this is a really nice pattern that I use in a lot of my projects where you use custom elements to define this stuff, and then basically you just don't define the element if it's not needed, and then the browser just simply kind of ignores it. So the final piece of our JavaScript puzzle is, can we avoid downloading things all together? Now, I appreciate you can have a little bit of very slow JavaScript. You could have an infinite loop, for example. It's a few bytes of code, but it's going to be very slow to execute. And you can, if you have a lot of expertise, you could have a lot of JavaScript that can execute quickly. But generally, more JavaScript is more problems. So how can we reduce how much we need? And Phil has covered some of this earlier. Can you first party your data? Rather than processing things on the client, can you pull things into your own database? So an example, again, in e-commerce is if you've got product ratings, rather than loading JavaScript on every page to show those ratings, pull them into your own database and chuck them out in your HTML. Simple as that. Following along those lines, can you wait for interaction to actually occur and then load in these big libraries? So I was able to reduce blocking JavaScript by a third way back before IMP or even first input delay was a thing, because there was a really slow third party that was rendering the kind of actual text-based reviews from customers on every single product detail page. Now, many customers never got to that content. They never even scrolled down. Many of them never opened the tab to even see it. So it's like, why are we wasting all of that time for no reason? So we just hooked it up to them opening that tab, and then obviously people who did were affected, but for the rest of everyone else, they got a faster experience. And then finally, do we still need all the scripts that we've got on our site? So go and check your tag manager for things that are long gone. You might have paid for something and no longer have a license for it. And similarly, check your polyfills as well. The web moves very quickly these days, so there might be some that you can get rid of. So that's everything on JavaScript that I've got for you. What about render and paint? Well, the first thing to understand here is that our DOM and CSS get combined together to build a render tree. And anytime either of these things change, we have to compute, our browsers have to compute what the impact on the render tree is and then on to painting. So we need to avoid unnecessary kind of repeating of that re-rendering process. We need to limit the scope of those invalidations in that render tree, so it's a more kind of compartmentalized problem. And we need to reduce elements that actually require that paint in the first place. So in terms of our dev tools, there's a new option in there. You can enable the new CSS selector stats collection. It does slow down the whole website loading process, so be mindful of that. But you probably still want to throttle your CPU as well. And so if you do a page load or you just capture an interaction, you'll get something that looks a little like this. And I know I scared everyone off from the flame charts earlier, but the main thing to look at is this selector stats thing at the bottom. So you can start to see how many elements were affected by these style recalcs. And if you zoom in and highlight on one of the kind of pinky purple blocks, it will actually tell you how many elements were affected and what the potential cause of the invalidation of our styles was. So you can actually pinpoint this all the way back to a piece of JavaScript that you may not have intended. So if we're starting to look at how do we improve this, firstly, we want to eliminate layout thrashing. So we don't want to be continually repeating this kind of render and paint process within our JavaScript. Paul Irish from Google has got a whole list of methods here available on GitHub that will trigger that reflow. So basically what you want to do is read from the DOM and write to it in kind of two big blocks rather than interleaving, because each time you're reading and writing, it might have to do that recalc. And ideally you want to do these just before rendering and painting so you can chuck them in a request animation frame callback. So in terms of our DOM, we want to compartmentalize it and keep it as small as possible. We want to avoid deeply nesting it forever and ever and ever. That does have an impact on our selectors. And we want to avoid having way too many siblings. So like, don't just attach everything to body. Because then when you do things like this, and you make a global change, it can percolate across the whole DOM. So if you are, I know that CSS variables are really exciting now, and it's great for things like design tokens. You can just chuck them into root and then reference them anywhere. But if you are modifying them, try and do it in a kind of compartmentalized area down to a single element rather than just making root level changes. And then there's a brute force approach, which is to encapsulate, effectively create a mini DOM using the declarative shadow DOM, which sounds very, very scary, but basically this is a non-JavaScript solution, like there's no JavaScript involved here, that will literally just create you a kind of blank, almost like an iframe, but kind of seamless on the page. So here you can see I'm styling this paragraph, and it's not leaking outbound because it compartmentalizes it down to that custom element. So that's a very extreme solution. And then the final one is deferring that layout and paint of off-screen elements. So you can use the Content Visibility API to do this, and you can actually prevent things like cumulative layout shift, where the web's going to move around as you kind of scroll and interact, by setting a placeholder size there as well. So I'm already running over time, but I've got just this last little section. So we've gone through all the kind of nitty-gritty of little things that we can do to tweak and improve what we already have today. But what's a more strategic approach? This is where the platform comes in, and it's really exciting to me because we can achieve so much with just HTML and CSS these days. It doesn't matter whether you're using a framework or not, you can still, ultimately you are outputting HTML and CSS, so you can use all of these things. And I've chosen 5 today that I want to just quickly flick through with some little demos, just to give you some inspiration to go and look at the web platform, see what it can achieve for you, rather than just jumping into the JavaScript land and installing NPM components. So, view transitions. There's 2 levels to this API. The first one, here's a little demo that I made for my workshop that I'll be showing on Wednesday. This allows us to animate between these states. It's a very simple bit of code that does this. And I've got this little Samsung A51, a very slow phone that I always carry around with me because it will, again, be humbling for most websites. But this literally, it's buttery smooth. It looks just like the demo on the screen. So it's impressive that this API can offload all of that work for us. And because this is powered by a CSS animation, it means that we can offload that to the GPU as well. So it's not even happening on our main thread to process this animation as well. So that's amazing. The JavaScript necessary to do this is literally basically 1 line. Really straightforward stuff, and you can fall back to just an instant opening and closing in this case. But where this gets really exciting for me is level 2. And this is actually a multi-page application, but you can see we've got a nice animation between the product listing page and the product detail page. So this just extends that API and allows you to achieve this purely with a little bit of CSS and 1 CSS attribute. So as long as you've got the same name on the source page and the destination page, that animation will occur. Really exciting stuff. There's no need to take on a massive single-page app framework if you just want to have that nice transition anymore. So that'll be really exciting. Second up, we've got speculation rules. These kind of go a little hand in hand with view transitions because they make the web genuinely instant. This is a platform feature. It's not just marketing. So I've got an e-commerce site here. Hovering over this product, and when we navigate to its page, you can see that's instant. That's throttled down to a slow 4G, which is why you've got the little warning in the network tab, and you can see the little green success indicator there. So that's being loaded by speculative pre-rendering. And how does this work with some maybe complex JavaScript? Nope, just a little bit of JSON. Simple as that. So literally a few lines, you tell the browser, this is what I want to pre-render, or you can even give it things like selectors, so you can just say, any link on the page or any link in this particular section. Give it a level of eagerness to go away and do this, and it will handle all of it for you. No input from you. Third up, we've got scroll-driven animations. These are really exciting because, again, they're taking away more JavaScript, and they use CSS animations, so they can happen on our GPU. So I've got a little example site here. Some of my friends in Leeds have a wine shop, and we're kind of animating the logo at the top so it kind of shrinks as you scroll. And you also see that the kind of shadows collapse behind each other as well. It's a really nice effect. Now, this used to require an intersection observer in JavaScript, so that's more JavaScript to execute. And then we'd have to modify our DOM to say this is now stuck to the top of the page, or this needs shrinking. So again, that causes style recalcs. But with this API, you can just do it with CSS. You get to use your keyframes, the API that you're already comfortable with. So that's really exciting. And it's added as a progressive enhancement. And on the topic of CSS, leads us on to number 4. One of the biggest blights on the web performance has been CSS in JavaScript libraries, which is a contentious topic, but they have some really great benefits. So typically, there's kind of 2 things, like co-locating your HTML and your CSS together. Makes complete sense, to me at least, and avoiding style collisions. So if you change CSS one place, you don't want it affecting everywhere else. And scoped CSS allows you to do just that. I've got a very rudimentary example for you here, just a component. You can see I don't even have a class name on this, and it keeps it all contained to that component. Really straightforward stuff. You can introduce a class if you want to, and then you can dedupe it, but this is how simple that API is. And the final one, the one that I'm kind of most excited about, is invoker commands. I produced a video on YouTube. There's a link to this if you want to look at it in more detail. Invoker commands builds on top of the native elements of HTML. So I've got examples of details. If you've not seen it here, it's like a disclosure element, and dialog, which is great for things like modal windows. And the great thing about these is they bring a degree of interactivity just to HTML without requiring much or any JavaScript. But the trouble with dialog is that you have to have JavaScript to open it. You can close it without JavaScript. You can't get into it without it. It's just bizarre. Well, the Invoker Commands API allows us to address that. So now you'll be able to specify a command that says show modal, give it a target, which is command 4, and you just give it the ID of the element, and it will trigger that command on it. Simple as that. But where this actually gets really exciting is how they're going to extend this. This is just kind of level 1, the first, dipping our toes in the water kind of API. So they're going to extend this with for more native elements as well. So here we've got a number input, and we've got the kind of traditional e-commerce example yet again, plus and minus next to our little number for the quantity, and you can step up and that down without any JavaScript. And the fantastic thing here when it comes to IMP is that, as soon as the user can see this, they can interact with it. They don't have to wait until some JavaScripts come down. We don't have to worry about presenting some kind of pending, uninitialized state here. They can see it, they can click it, it works. So that's really exciting. And then the final piece here is that you can also create custom commands as well. So rather than having to add click listeners all over the place, you can just add to your kind of receiving element the behavior that listens on that command and executes it. So I could go on, and I know for a fact that our mystery speaker, who shall not be named, will be covering more similar things along those lines tomorrow. But my main point is this, right? JavaScript frameworks and libraries and that kind of ecosystem is quite turbulent. Fads come and go, but the web platform is knowledge and implementation that you can depend on for decades. It's really useful for you and your users. So it's worth looking for solutions there first, rather than just jumping straight into your, installing NPM libraries, as I say. So just to quickly summarize well over time, if you're looking at improving interaction on the web, collect and analyze your own data as much as possible. Get into the nitty-gritty of things. Consider the uninitialized state of your elements. Prioritize visual feedback by yielding to the main thread. Let it breathe. Minimize the work to be done through throttling and debouncing, etc. Abort work that you don't need anymore because you're just processing it for no reason. And use the platform wherever you can. I've been Ryan, and you've all been smashing.
Excellent, Ryan. Would you join me?
Yes.
I don't know how much time we have, probably not that much. Okay, we'll have one question, rest at fireplace, I'm told. I still have a strong feeling that there is this very concerned citizen that keeps throwing up questions. One of them is it still painfully difficult to make React applications blazingly fast these days?
I think it depends on your definition of blazingly fast. You have made it difficult for yourself by choosing that. React was never actually designed to be fast. That's how it's kind of marketed, but it wasn't. That wasn't its original purpose. There's a lot of foot guns. Obviously, it kind of renders by default, so it assumes that it needs to check whether something's changed. So you have to be very careful with things like how it tests for equality on state. So if you pass in like an empty array as like a default, each empty array you create is a new object, so it thinks that it needs to re-render. You need to make sure you're passing the same one back so it knows that it doesn't. So just be careful with that kind of process. And that's I try to avoid it as much as possible.
Excellent.
So I have a wonderful number of
so
tips.
Amanda, I have 1 minute 50. Can I ask more questions?
Oh, yes.
150 is running. Okay. The answer is it's
No.
like uppercase no. So I better be respectful. So if you have some questions for Ryan, please come to the fireplace. So it's also kind of an opportunity for you to breathe and come down a little bit before the next session. Otherwise, we'll be running from session to session. That's not needed. Well, thank you so much, Ryan, for all the wonderful insights. Please.
Thank you, everyone.